White box testing. The box testing approach of software testing consists of black box testing and white box testing. We are discussing here white box testing, which also known as glass boxes testing, structural testing, clear box testing, open box testing and transparent box testing. It tests internal coding and infrastructure of a software, focus on checking of predefined inputs against expected and desired outputs. It is based on inner workings of an application and revolves around internal structure testing. In this type of testing, programming skills are required to design test cases. The primary goal of white box testing is to focus on the flow of inputs and outputs through the software and strengthening the security of the software. The term white box is used because of the internal perspective of the system. The clear box or white box or transparent box name denote the ability to see through the software's outer shell into its inner workings. Developers do white box testing. In this, the developer will test every line of the code of the program. The developers perform the white box testing and then send the application or the software to the testing team, where they will perform the black box testing and verify the application along with the requirements and identify the bugs and sends it to the developer. The developer fixes the bugs and does one round of white box testing and sends it to the testing team. Here, fixing the bugs implies that the bug is deleted, and the particular feature is working fine on the application. Here, the test engineers will not include in fixing the defects for the following reasons. Fixing the bug might interrupt the other features. Therefore, the test engineer should always find the bugs, and developers should still be doing the bug fixes. If the test engineers spend most of the time fixing the defects, then they may be unable to find the other bugs in the application. The white box testing contains various tests, which are as follows. Path testing. In the path testing, we will write the flow graphs and test all independent paths. Here, writing the flow graph implies that flow graphs are representing the flow of the program and also show how every program is added with one another, as we can see in the image. And test all the independent paths implies that suppose a path from main to function G, first set the parameters and test if the program is correct in that particular path, and in the same way test all other paths and fix the bugs. Loop testing. In the loop testing, we will test the loops such as while, for, and do while, etc., and also check for ending condition if working correctly and if the size of the conditions is enough. Condition testing. In this, we will test all logical conditions for both true and false values, that is, we will verify for both if and else condition. Testing based on the memory, size, perspective. The size of the code is increasing for the following reasons. The reuse of code is not there. Let us take one example, where we have 4 programs of the same application, and the first 10 lines of the program are similar. We can write these 10 lines as a discrete function, and it should be accessible by the above 4 programs as well. And also, if any bug is there, we can modify the line of code in the function rather than the entire code. The developers use the logic that might be modified. If one programmer writes code and the file size is up to 250 kilobits, then another programmer could write a similar code using the different logic, and the file size is up to 100 kilobits. The developer declares so many functions and variables that might never be used in any portion of the code. Therefore, the size of the program will increase. Test the performance, speed, response time, of the program. The application could be slow for the following reasons. When logic is used. For the conditional cases, we will use OR and adequately. Switch case, which means we cannot use nested if, instead of using a switch case. As we know that the developer is performing white box testing, they understand that the code is running slow, or the performance of the program is also getting deliberate. and the developer cannot go manually over the program and verify which line of the code is slowing the program. To recover with this condition, we have a tool called Rational Quantify, which resolves these kinds of issues automatically. Once the entire code is ready, the Rational Quantify tool will go through the code and execute it. And we can see the outcome in the result sheet in the form of thick and thin lines. Here, the thick line specifies which section of code is time-consuming. When we double-click on the thick line, the tool will take us to that line or piece of code automatically, which is also displayed in a different color. We can change that code and use this tool. When the order of lines is all thin, we know that the presentation of the program has enhanced. And the developers will perform the white box testing automatically because it saves time rather than performing manually. Test cases for white box testing are derived from the design phase of the software development lifecycle. Data flow testing, control flow testing, path testing, branch testing, statement and decision coverage. All these techniques used by white box testing as a guideline to create an error-free software. Thanks for watching.